Good afternoon, Year 12 single mathematicians. Just going to go through a request from exercise 11E, question 6. This is the exercise where you've got constant acceleration, but you're encouraged not to use the SUVAT formulae. So I'm going to try and do every single one of these questions without using SUVAT. So first one, we've got a train travelling from A to B, and the distance from A is given by this formula, and it takes 40 seconds to get to B, and we want to find AB. So not too difficult for first part. AB would be equal to substituting 40 seconds into this formula. So 25 40s, subtract 0.2 40 squared. If you type that into a calculator, you get 680 meters, which kind of makes sense. Right, part B, you want to show that the train travels with constant acceleration. We've got a formula for S, or its displacement, and we would like a formula for acceleration effectively, so you need to differentiate twice. So velocity would be ds by dt, which would be 25 subtract 0.4 t. The velocity is changing because I can vary t and the number would change, but I want acceleration, which is dv by dt, which is equal to minus 0.4, which is a constant, as is not dependent on t. Not dependent on t. And that's pretty much it. And then part C, the actual difficult part, is the same question now, but you've got a bird which is starting at B, moves in the opposite direction to the train with an initial speed of 7 meters per second and an initial acceleration of 0.6 meters per second squared. And at some point, the bird and the train are going to be above each other or next door to each other. So let's just say that's the train there, and that's the bird there. At some point, the train and the bird are going to be, the bird's going to be just above the train. And let me just check the question. But they want you to find the distance from A. So distance from A. So the distance they'd like you to find is this, which I'll call x. And okay, let's try and do that. So this distance x is given by the formula right at the start, s equals. Now, I don't know the time when they are above each other, so it would be x equals 25t subtract 0.2t squared. And now I want a formula for the distance travelled by the bird. And the key thing is you use part A. The entire distance A to B is 680. So this distance would be 680 subtract x, and we will need to use that at some point. I really want to use SUVAT right now, but I'm not going to. I'm just going to use what has been given, which is the acceleration of the bird. So A is equal to 0.6 meters per second squared. I can work at the velocity by integrating to get 0.6 t, but remember to include the plus c. And then there's enough information for me to work out what the plus c is, because it tells me the initial speed is 7 meters per second. So when t is equal to 0, V needs to be equal to 7, which implies C would have to be equal to 7. So the formula for velocity is 0.6 t plus 7. And then work out the formula for its distance or displacement. So we would have S would be integrating V with respect to C, which would go to 0.3 t squared plus 7t plus another constant. I'll just call that constant d for now, just to show they are different. And that would be the distance from B. So distance from B, there's enough information now for you to work out what the plus d would be. So when t is equal to 0, S is equal to 0, because it obviously starts at B, which implies d would be equal to 0. So the formula for this would be S equals 0.3 t squared plus 7t plus 0. Now, that's the distance from B, but we want a very specific distance. We want it to be 680 subtract x away, so I just substitute that in. So 680 subtract x is equal to 0.3 t squared plus 7t, and then that equation there and that one there are simultaneous equations with x and t, so you need to solve these simultaneously. I'm going to add them together. Just call that 1, call that 2, add them, because the x's disappear. 680 equals 0.1 t squared plus 32t, make that equal to 0. And then I'm going to cheat and use my calculator, solve an equation thing on the calculator, find the quadratic, and we've got a quadratic 0.1, 32, negative 680, to give me two answers. T is 20 or negative 340, obviously it can't be that. And then I just substitute t in to work out the actual distance from A. So which one would be the distance from A? It'd be back into number 1. So substitute into 1, and you get x equals 25 20s minus 0.220 squareds, which gives you 25 20s, subtract 0.220 squareds, 420 meters away from A, and that would be it.